Welcome to the second lecture on quantifiers. In this video, we're going to get into some more details about how quantifiers and variables work together. So the first thing we're going to talk about are, again, the two quantifiers that we're going to use, the universal and the existential. I'll briefly say something about well-formed formulas, and then we'll talk about the distinction between free and bound variables. So remember, the idea behind a variable is that it works kind of like a name in that it sits in an argument spot of a predicate. So if we have a predicate, let's say, if we have a predicate like tet, and we had, we're looking in Tarski's world, right? We could use something like a as a name. But with variables, variables act kind of like names in that they sit in these argument spots, but instead, but they're also totally unlike names in that they don't refer to a specific object. So that's one of the key features that distinguishes variables from names or constants. Names or constants refer to a specific object, but variables will not. Okay, so the basic idea behind a well-formed formula, or as we'll sometimes write as a shorthand, WFF, or WIF, as is sometimes known, is almost like a sentence, except that the some of the names or constants might have been replaced with a variable, but we don't yet see any particular type of quantifier, or there are what are called free instances of variables like this x here. So if we think about variables as we've seen them in other contexts, right, you might have, like in math, you might have seen formulas that say something like x plus x is equal to 2x. Here, right, x doesn't name a particular number, right? You can plug in any type of number you like, and then this equation will tell you about some relationship. So if x, for example, is refers to 3 or denotes 3, then you know 3 plus 3, that sum of that is going to be identical to if you took 2 and multiplied it by 3, right? So in that case, it would both be 6. Same thing with the variables that we're going to use in our language. X here can stand for any particular, or can denote any object in the domain of discourse. So one of the things that is sort of implicit in mathematical uses of variables is that there's typically a universal quantifier implied, right? So for what I just had with that formula, the idea is that that formula holds for any number that you apply it to. So strictly speaking, it would mean for any x, x plus x is equal to 2x. There's an implicit universal quantifier there. Because we're going to have two different types of quantifiers in our language, we need to be clear about which particular quantifier we're using. So for example, if I put out here the claim, or how you use a universal quantifier for all x, tet x, what this is saying is that everything in my domain, so everything in the Tarski world that you're looking at, is a tetrahedron. So this is true just in case every object in Tarski's world is a tetrahedron, and it's false if there's at least one object that is not a tetrahedron. Alternatively, instead of having the universal quantifier, we could have had instead the existential quantifier. And if we have the existential quantifier, this is now saying something different. This is now saying there is at least one object, right? There is some case x such that x is a tetrahedron. So this formula would now be true just in case there is at least one object in the domain of discourse that is a tetrahedron. So the difference between the three cases, right? So the three cases is where we've got universal x, tet x, and we've got the existential case, right? There exists at least one x such that x is a tetrahedron. And this third case, just tet x, is that in these two, so in this formula and in this formula, we say the variable is bound. Oh dear. There we go. And here, in this case, the variable x is free. So it should be clear, these arrows are not actually pointing to the quantifiers, right? These arrows are actually pointing to this instance of the variable right here. So here, x is bound by this quantifier, the existential quantifier. This instance of x is bound by this quantifier right here. And this x in this formula is not bound by any quantifier at all, right? So we say instead that it is free because we don't have a quantifier that tells us whether this x, this instance of this variable, applies to just one particular instance or at least one instance, or if it applies to all of them. Okay, the reason why we make this distinction, in addition to being able to use two different quantifiers, is there might be multiple instances of some quantifier, and it'll be important to distinguish which variable is being bound by which particular quantifier. So let me walk through an example here. Make some space. Oh, that's not what I wanted to do. Okay, so I want to consider two different sentences. Let's see if I think I can do this relatively quickly. So let's consider the following sentence. So we're going to say there exists an x, so there's at least one object that is a tetrahedron. So we have here now a quantified sentence. It's an existential sentence. There exists at least one tet. And we might want to combine that now with a conjunction. We say, okay, there exists an x such that small x So the thing to note is that this instance of x is being bound by that quantifier over there. And this instance of x is being bound by that quantifier there. And this sentence is ultimately a conjunction. It's conjoining two different existential claims. So this sentence is true just in case there exists at least one tetrahedron and there exists at least one object that is small. So that would be satisfied in a world where you have, say, a large tetrahedron, so this object is large, and then you also have a small dodec. That's different than the following sentence. Suppose instead of having the conjunction of two existential sentences, we said instead that there exists an x, and we say x is a tet, and x is small. Here, the variable x, as you see it in two instances, is being bound by the same quantifier, that existential quantifier up front. So unlike above, where we had two instances of an existential quantifier, and the different instances of the variables were bound by the two different instances of the existential quantifier. In the second sentence, we have a single existential quantifier, and that's binding both of these instances of X. And we make that clear by realizing that, oh, we have here an open parenthesis, and this quantifier, the existential quantifier, ranges over all the instances of X that are within the scope of this these parentheses, right? So the scope of this existential quantifier ends right here. And then we've got and then this existential quantifier, it binds all the variables up to that point. Here we've used the this open parenthesis to indicate that this existential quantifier out front is actually binding all the instances of X that occur inside those parentheses. And this sentence will actually mean now something very different, right? We're saying there is at least one object that is both a tetrahedron and is small. So this second sentence, maybe I'll call this sentence 1, and I'll call this sentence 2. Sentence 2 is going to be false in the world that we just developed to make sentence 1 true. That's a terrible looking one. For sentence 2 to be true, what we need is a tetrahedron that is small. So 2 is made true in a world where there's at least one tetrahedron that's small. So the sentences actually come to mean very different things, and the only difference is to note the ways in which we have bound the instances of the variable X. Okay, so sometimes this will make a difference in terms of how to make the sentences true, and sometimes it won't. So for example, right, 1 and 2 have different meanings, and one of the ways we can show that they've got different meanings is that there's a way to make 1 true, but make 2 false, right? This world right over here makes 1 true, but 2 false. Sometimes, however, the sentences will mean different things, but actually come really close to finding, or will come really close to being true in the same worlds. So here's what I have in mind. Let's say instead of having an existential quantifier out front in these 2 sentences, let's say instead that I put a universal quantifier out front. And now I want to compare these 2 sentences. The same thing applies with respect to binding. That's to say, this instance of X is being bound by that particular universal quantifier, and this instance of X is being bound by that universal quantifier. Here, right, in this bottom case, again, we have both of these instances, this X and this X, are both being bound by that universal quantifier. So what sentence 1 is saying, and when we use the universal quantifier, is that everything is a tetrahedron and everything is small. Notice that this world now would no longer be true. We'd have to have a bunch of tetrahedra, and each of them would have to be small ones. So 1 is made true so long as everything in the world is a tetrahedron and everything in the world is small. Now it turns out that the only way to make 1 true is to have every tetrahedron or every object be both a tetrahedron and be small. And that is a way of expressing 2. 2 saying everything in the world is a small tetrahedron. So 1 and 2 will actually be true in all the same worlds, even though it turns out that the meanings of the sentences are different. And we can see that by the fact that in the first sentence, we have a conjunction again, while in the second sentence, we have a universally quantified statement. Okay, so in this lecture, you should have been introduced now to the idea of well-formed formulas. So well-formed formulas are just like sentences, but where you have one or more occurrences of free variables. And the difference between a free variable and a bound variable is, in the case of a free variable, there's no quantifier that tells us whether we should apply it to everything in the domain or whether we should apply it to just at least one thing in the domain. A bound variable is a variable that has some quantifier out front that tells us whether it will be quantified universally or existentially.